Now that I've got the lawyer thing out of the way.
Yeah, there we go. What was that? Yeah. So we'll just give it another minute or two. But again, I've got Margie, Randy, and Lori. Anybody else?
So Chris, next week when I'm you, do I actually have to grant Joe the ability to record, or is that automatic?
Yes, so it's one of the options if you're signed into the Rask account. In the options beside the person's screen there.
Oh, I know where
there's
it is.
the 3 dots, yeah, and it's in there.
I got it. Yeah, I know what to do.
And if you don't, I have the password, so I'll just force my way in.
Yeah, there you go.
No,
that works.
You'll be fine. You won't need to resort to that.
There are a couple of people on the screen that I don't know, and we might ask if you're interested. You could say how you know about us, like Dwayne Weaver there.
Well, Randy, the first time I knew about you was right after I got my telescope at Christmas, and I watched your Astro Cafe from December, and you all got me so excited. I was like an excited newbie. I finally got pushed over to, I think, Bill, which is Bill's iPad tonight, and Bill told me you didn't want to curb my enthusiasm, but I should be looking patiently, don't worry about a camera yet, those sort of things. So that's how I got involved, and I got David was leading the first I can't remember the name of the group now, but your newbies group. So I attended that, and I was here at the Astro Cafe last week. I thought I'd just come back and listen because you guys are so interesting.
What a good commendation. Well, welcome.
Thank you. And I thought I'd cheat. I had the author of this photo, but someone took a picture of the full moon in January, and sometimes it's called a wolf moon. So I thought I'd cheat that way tonight.
That's a good one. It's not cheating.
Great photo.
It's the only moon we're going to be able to see. You know?
Maybe. Yeah, it's kind of seems to be the way it's going.
Unless Randy has his little handheld one.
Yeah, there we go. One piece of good news from my front, I did manage to get this week. Did anybody else get? It arrived on Saturday by courier, so I'm hoping a lot of people who hadn't gotten them got them this week. So that's good.
I'm still waiting.
Yeah.
Have the calendars arrived yet?
No.
Okay.
I don't even want to be on the screen here. Like I don't, I had to think about actually coming. So
yeah.
Maybe I should do it, but it's not the same thing.
No,
that's a good book, right?
That's a good one.
Yeah, David suggested that, so I ordered it, and it arrived sooner than I thought. I was hoping I'd get the one you guys talked about, but I got this first.
Yeah, so the other one, which is the Rask publication, I think Nicolette, she wrote it, and the almanac, that's actually available at Boland's, actually. They still have copies.
And we did order some too, didn't we?
I have them. If somebody would like one.
Arrived, didn't it? Yeah.
They arrived like months ago. Yes, yeah. So
one thing I think we should do, because I think Reg may still have some beginner's observer's guide, is we could put a little list somewhere on the website of what we actually have and who has it if anybody wants something, rather than ordering them from Toronto, because it seems like getting them here at the moment is just not happening. So
that's a bit of a problem.
And now it's going to be on their end now for a few days, so that'll be.
Chris, I do have copies if people are interested in them, and they're selling for $12, and we make 8 cents per copy.
Excellent, yeah. But you got to sell lots of those.
Yeah, on Mars, they're virtual and invisible.
Yeah. Well, thank you everyone for joining us this evening, and it looks like we've got 26 people signed in so far. So Margie, you had asked to present another astronomer. So if you're ready, you may take it away.
All right, I will. May I share the screen?
You should have that permission, so please carry on. That the ring of Saturn on your screen.
Yeah.
Can you see that?
We're still on your Zoom screen at the moment. Now we can.
Anything you can see?
Yes.
A woman of
Yay.
Ah, okay.
Yay.
Wow.
All right. I'm just going to get rid of my. Oh, sure. Cover that up. You didn't see that.
Yeah, you should have seen. You need to put it in the slide view, or yeah, start the presentation.
All right. You can't see anything. All right, here we go.
Nope.
Yeah, if you press play,
we can see it.
We can see your. Wait, it's in the keynote view, not in the slideshow view.
Can you see a woman of astronomy?
Yes.
Except we see the other slides as well.
So we're getting a hint as to what is you might be going to tell us.
Yeah, just hit your play button.
Oh dear.
I
did.
Good.
Yeah, we've got it now. So it should be running.
Andromeda, Cassiopeia.
All right. All right, so just a minute here. Hang on. So I'm going to hit the play button and see if we get a full screen without all the information. If you see all the information, just block it out of your mind.
Yeah, we've got just the
yeah, you're good now.
Screen now, so you're good. Yeah, there we are.
All right, you have full screen.
Ah, Urania.
Urania.
Say yes or no.
Yes, we have a full screen.
But we're on the third slide now.
Oh no! Jeez. All right, I'll just leave it like this now. So you see the first screen, a woman of astronomy?
Yeah.
Yes.
All right, here we go then. And I won't hit play then. All right. So now that you know the answer, a woman of astronomy. She is neither alive nor deceased. She is neither breathing nor obsolete. Who do you think she is? Okay, you don't know.
Not just with that clue.
I thought she might be a constellation, but that was a wide guess.
That's a good guess, Oliver.
She is the Rask Seal woman of astronomy. Do you know who she is?
Urania.
And the answer is no.
Okay, you don't know who she is. Okay,
Urania, she's on all our crests and everything. So all over the place.
Urania, the muse of astronomy. Urania is the classical Greek pronunciation. Urania.
Ooh. Margie, we're still on your first screen.
No.
First screen. Yeah, I know. I'm sorry.
I think you have to use the arrows, Margie.
So that didn't do it?
Nope. I made it better. Oh, no. That's just.
Now it's gone back to the kind of layout.
Honestly, this used to work.
Click the down
All right, so
button.
I'm going to press play again.
Press play, yeah, and then try the right arrow to see if it will advance.
Or the down arrow.
Yeah.
Hit the down arrow.
Is it down for keynote?
Because then it moves down.
Actually, it works both ways. So you see the first screen, a woman of astronomy, correct?
Yep.
Well, it's still in, for me, it's still in the layout mode.
Oh my gracious. All right, do you see the second screen?
Yes.
Yeah.
Perfect. Let's just go with this.
Let's just do it this way. Yeah.
Let's go with this. All right. So Rask Seal, woman of astronomy, do you know who she is? Now you do. Urania, can you see her?
Not yet.
Nope.
You'll need to click on that slide, number 3.
You need, yeah, you need.
I did it.
Now we got it.
Now you got it. Maybe it's just slow. Urania, the muse of astronomy. That Urania is the classical Greek pronunciation. Here she is in a statue, which you can see, correct? All right. She has stars on her. Stars.
Come back.
What?
We're back at the beginning.
Press the other buttons.
I hate technology.
My gracious. All right, I'm going to stop this and start again. See if that helps.
Well, you look good.
Margie, if you share the screen rather than sharing the particular thing, you'll probably be able to control everything better.
So it says share screen at bottom, which I'm doing. That's the green one.
Yeah.
And then
And now pick the screen to share.
Ah, right.
Top left corner.
You see anything?
We should.
Yes.
You see the
Back
first
to the
slide?
same thing again.
All right. Well, that's a good thing because that's the first slide. Do you see the second slide?
Yes.
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 Rask Seal, Woman of Astronomy.
I've always
see
wondered who she
that?
was.
I know. All right, here we go. Third slide. Do you see a statue of Urania?
Yes.
Yay. All right. Urania is muse of astronomy. And as I've now said, this is now the third time, Urania is the classical Greek pronunciation. The Greek pronunciations have to do with the accents on the ends of the words. All right, you see her holding a celestial sphere? Do you see her holding a celestial sphere? Oh, goody. Okay. She's holding a celestial sphere. My connection is unstable, it says. She in her left hand. In her right hand, she has a pencil. Sometimes it's called a rod. She has stars on her robe. And sometimes in her, I'm sorry, that's the other left hand. She has a celestial sphere in her left hand and a pencil in her right hand. And sometimes you will see her with a compass in her right hand, because of course the compass was for navigation.
And the celestial sphere implies the Greeks knew perfectly well that the Earth was a sphere.
Absolutely.
Aha. All right, now you've seen 9 muses of the arts. Okay, good. So there are 9 muses of the arts in Greek mythology. And as you can see, Urania is the second one from our right, holding the globe, and she has a stick. Okay. All right.
So how come
Urania is the daughter.
Why was astronomy considered an art by the Greeks?
Ah, you ask such good questions. That's because the Greeks did not differentiate between science and art and history, any of those things. They were all considered to be arts. All right, she is the daughter of the sky god Zeus. Her namesake is her primordial Titan grandfather. Primordial, obviously, he's the first. He's the big Titan. Uranos. Uranos, because we're still in Greek. Uranos, which means the embodiments of the sky. Urania's role in Greek mythology was, with her sisters, to entertain the other Olympian gods and goddesses by performing songs and dances and telling stories centered around the greatness of Zeus. During the Renaissance, Urania was considered the muse for Christian poets. She is the namesake for observatories, asteroid 30 Urania, but now of course we're in Latin, so it's Urania. 18, so that's the asteroid 30 Urania, 1854. Emblems, ships, and printed material. And her name is part of the title of the Johann Bayer 1603 Star Atlas, Uranometria, which David owns, measuring the heavens. And this is how it got, this is David's Uranometria got me started on who the heck she was.
Which David?
Oh, Lee.
Yeah, we were talking about star atlases at one of the beginners group, and there was some talk about William Bell products not being available, and then they did get bought up by Sky and Telescope is selling them, and I did receive my copy. I think other people have had this for a long time. I know Bill has the original 2-volume version. I've got the single volume version.
Yes, maybe.
No, I have 2 of the new ones.
Oh, okay.
I ended up with a second when I bought up all of Nelson's gear. He threw a uranometry at me.
Oh, good.
All right, maybe you can show it to us after.
Yeah.
All right. So the Rask seal, which was incorporated in 1905, says quod ducit Urania, because now we are in Latin, Urania. Second accent on the second syllable. Where Urania leads, we follow. That's what quod ducit Urania means. There she is in her many, many, many different images. The end.
Yeah.
Thank you.
I didn't know this.
Yeah, it's very interesting. I've seen the name. That was as much as I knew. But, yeah.
Just to make things a little more complicated, in the 19th century, homosexuals were called Uranians, and I have no idea why. It doesn't seem to be much of a connection. I don't know if anybody knows. They were.
So does someone have a copy of Uranometris they can show us? It's a big book. There we go. Uranometria. Show it sideways, David, so you can just see how thick it is.
Yeah, it's
oh boy.
God. Oh my gosh.
It's quite thick.
I have the 2-volume set.
It's hard to show the
You
insides of
can
it.
get the 2-volume set, and we've done that. We have the full volume, the 2-volume, Northern Hemisphere, Southern Hemisphere, taken of the pages from that we want from the second hemisphere, the Northern Hemisphere. Miles has put them in a binder so we can take them out to the field and just take out the page that we want to use. It's very convenient and it's not really destructive because you still have all the pages in a loose leaf binder, but just for the Northern Hemisphere, because we're not going to be looking at the Southern Cross and farther south, unfortunately.
Yeah, everybody seems to have a personal way that they use atlases. For hardcover atlases, I tend to use them as reference volumes inside. I don't use them outside. My outside stuff is usually like larger versions, which are laminated, because unfortunately everything turns into like sopping wet newsprint when you're out in the dew. So.
Yeah, and that one does not have outdoor paper.
No, this one doesn't.
Yeah.
So if you're looking to get one, this is Shop at Sky, which is the store of Sky and Telescope, and they have put their Wilman Bell page at the end there, and this is what they currently have available. And notice it's temporarily out of stock, so you were lucky to get one at the moment.
Yeah, I have responded to their email saying that they finally had them. And yeah, they're quite heavy. Basically, I had them ship 17 pounds of this stuff. I bought the other 2 versions, the seasonal versions of it as well, of the guide, of something called the Night Guide. So the Night Guide comes in 2 seasonal versions and
this one, these here,
Southern Sky. Yeah, the Night Sky.
Yeah, you got those, yeah.
Yeah.
Now, one thing, and I don't know if they've done it for the Wilman Bell, is Shop at Sky has a you buy up to so much weight and they'll ship it even to Canada for a that's their basic rate. And it was fairly generous. Now, I think that book would exceed it, but I don't know if they're doing that, if the books have.
I'll tell you, I was very surprised by the shipping cost. It was very nominal. It was very low, actually, given it was 17 pounds worth of books.
Yeah, because normally it's not really worth buying things from the States because the shipping charge blows it out of the water. But their regular stuff from their shop at Sky before they had the Wilman Bell had quite a reasonable shipping price. So if you're interested in something, have a look there because it's maybe not out of the question.
Yeah. Any of the RASP publications, either you can get them through us if we're ordering them, or you can order them from the national page. But many of them are actually available locally as well. Like Boland's has a number of the RASC publications.
Yeah, because RASC was another one where the shipping price often has not been very favorable from. So
back when I was observing with my old Volkswagen camper van, I could take the uranometry with me because there was in the back of the van, I could keep them under cover so they didn't get dewed up. And I even had a set of transparencies made up with different eyepiece fields of view that I could lay over the pages so I could star hop with fairly good ease given the scale of the uranometria.
Yeah, those kind of things that Dave's talking about were quite common before sort of digital versions of atlases. And nowadays, I mean, they're basically field of view definitions that you use in software. But I guess a lot of people made up these kind of wire shapes or these little templates they could use over the covers, the books themselves.
Yeah.
So
I have a set for my Sky Atlas 2000 as well, and that's a laminated version, and I'd still use that because I don't have a go-to scope. Mine's a push to.
I've never had a problem with mine being wet. I just get them wet, bring them back inside, and I leave them closed up and they dry out, and never had a problem.
So what you're saying is that Urania she's a valuable gal.
Oh yeah,
absolutely.
Thank you, Margie.
As always.
Yes. So John has posed an interesting question there, and some people have been participating in the quiz by chat, but nobody's got it yet.
What was the question, John?
I wrote my first computer program in 1958.
Yes.
The day that a computer was acquired by the physics department at Saskatchewan, where I was an undergraduate. And I just asked if anybody knew what the computer was called. It was about the size of a normal desk. It used vacuum tubes.
Did it have a set of switches at the front, John?
Pardon me?
Did it have a set of flip switches at the front?
No.
Okay, so I know what it's not.
No, it had, the only input was punch paper tape. And the only output was punch paper tape.
Did the name of the computer begin with a U?
No.
Oh.
Is it an abacus?
Begins with an L.
An L?
Yeah, abacus. No, that's an interesting. This one did come after the abacus. Just for your information.
Did you have to wind it up in the morning to make it work?
No, but you had to turn it on and wait for the vacuum tubes to warm up.
And
then you had to hope that the vacuum tubes did what they were supposed to because they were kind of quirky.
So if
my father's job in the Royal Navy for a while was to try and get one of their first computerized gunnery systems, keep it running. And it was the same issue. And they'd get out to sea and start trying to fire it up, and then it would fail because some tube had died somewhere in the middle there. So then they'd have to call for these guys to go. And one of the ships was in Singapore. So they actually flew from, this is in the early 1950s, flew from Britain to Singapore, which took 4 days to go and try and fix this stupid thing.
That's where the money went.
Yeah.
Jeez.
So how many of you guys learned how to program in Fortran 4?
First language.
That would be me.
Yeah, first language.
I feel like a young guy. Mine was Fortran 77.
Oh,
yeah,
wow.
The modern era. Now.
1963, it was Fortran, but I can't remember which number.
Dwayne, do you still program?
I do a little bit of coding here and there, yeah, but it's totally different.
In more modern languages, right?
Yeah. I code.
I had a summer job where I had to do a bunch of calculations that involved square roots, and the calculator I had was mechanical. It would sit there, generating square roots.
Oh yeah.
Yeah.
Fortran was a long way in the future when the computer that I'm talking about arrived. And it was really at the time when mechanical calculators were very common. You know, the things you cranked.
Mm-hmm.
Yeah.
You better put us out of our misery, John, because I don't think anyone's going to get this L-named computer.
I just wondered if any of you might have heard of it. None of you may be old enough, but it was called an LGP30.
No.
And they probably didn't make very many of them.
Wow.
It was more of a curiosity than a computer of any real use, but we had it in our laboratory, and it was fun to play with because we could do sort of very primitive programming with it.
Did it actually have a purpose?
Before the days of the big computers coming out.
John, was it actually used in practice?
Well, no, only for learning the rudiments of what computers might do in the future.
Okay.
Yeah, so I guess for its time, it was relatively small.
It was
huge.
When I was in grade 7 or 8, one of the kids in my class was the son of an executive at London Life, and he gave a little talk at school about going to New York with his father to purchase a computer records keeper for London Life. It took an entire floor of the big building of London Life downtown and had to be specially air conditioned because of the heat of the vacuum tubes. And all it did was remember things. It didn't think of anything. It didn't recreate. So that's when you're talking about, John. It was a long time.
What year was that?
56, 57.
Yeah, the same time then.
Yeah, it was. I wasn't quite to university yet.
You could probably fry your eggs on the top of this one. It did get pretty warm.
Yeah, that caused a huge.
Later, I was making an amplifier to use in a neurobiology lab with.
Here it is, LGP30. That's it.
Does it bring?
I remember it well.
Looks like a chef's freezer.
Well, it's pretty modern. It even has buttons on the front.
Yeah, that's amazing. Oh,
I don't know if they did anything, but
is that a real interface, John?
That was not part of it.
Okay,
you can see the tape writer on the side, though. You see it on the left side there.
That looks like that's how you print out the ticker tape that feeds it, right?
That looks like a freezer box for taking on holidays.
It does, doesn't it?
So Dorothy was going to talk about an amplifier.
You know, this might be a later version. I don't remember ours having any buttons like that.
Well, look at that, John. It has that on this interface there.
Yeah, I don't think ours had that.
Yeah, you can tell it to print.
This might have been a later version.
Wow.
We certainly didn't have a typewriter input.
So you used a pencil and paper to poke the holes? Was that the?
Yes.
No, we had a little mechanical punch.
Exactly, a ticket punch like a conductor on a railway.
Right.
Yeah, we used paper tape as well, but that was the 70s, and we used a Frieden, F-R-I-D-E-N, and it was also used by City of Victoria, and they controlled all the traffic control. Programming was all done through punch tape like that. It ran that way until about 2000.
I worked at a Toyota dealership when they used to use telex to order your cars and things like that, and they just transitioned, like they had computers, and all it really was the computerized version of a telex where you would type what you wanted, and just like you did on the telex, but instead of doing a ticker tape, it would send an electronic signal, so you got a visual screen of it. That was the final change, but everything else we did was exactly the same.
Well, that was pre-internet, so you didn't have a connection, so that was still telephone based.
Yep.
type, send.
Yes, exactly, and then wait.
And then wait a long time. Yeah.
Can we hear what Dorothy was saying about her amplifier?
Yeah, let's hear from Dorothy.
Yeah, Dorothy. Yeah, you got cut off
there. John, you reminded me of putting together an amplifier for a neurobiology lab from a Heath kit with tubes. I had already seen huge hand-blown tubes at the Hopkins Marine Station, Stanford University, from the 1930s, where the first biologist to make recordings from inside a cell had made an amplifier. But what I'd like to point out is for us astronomers is to remember that the Voyagers that are still going out beyond the solar system have tubes. It's very stable. One of amazing success of what technology can do as it looks, keep our fingers crossed, JWST will be too many decades later. But if you're careful and plan carefully, and the stability of vacuum tubes for under the right conditions is, as I understand it, is certainly superior to the digital. It's there as long as they aren't sat on or.
Well, audiophiles like amplifiers that run on tubes, you can still buy them. I think Russia is the only place that makes them.
Yeah, they're no longer made in North America, but you're right, they're Russian based now.
Yeah, yeah.
I have a shortwave receiver that has tubes in it. My old Quad AM3.
Yeah, that's a fairly
and back in 1974, I built a Heathkit TV that it worked until 1981.
And I have an antique Marantz amplifier, which is tubes as well.
I have something here that you've probably never seen. It was a gift that was going to be given to Hitler when he won the war. Okay, designed by a Swiss watchmaker. Have you ever seen something like this?
I have.
Yes.
What's a Koenig?
Yes.
I've used them.
Calculator.
Absolutely. We used to call them coffee grinders.
These are amazing. This is the world's smallest mechanical calculator.
Oh, they're elegant.
They're wonderful machines.
Where did you get that?
We use them in the field.
Where did I get it? A long time ago when I worked for BC Hydro, there was an estate, they were selling off a whole pile of junk, and I got a couple of these. And if any of you have them and you don't want them, please give them to me. They're worth about $3,000. Wow. You crank it and it calculates. So there you go.
You made my day, Gary. That's the first time I've seen one for 40 years.
My wife used to use one when she was a navigator for a guy that did rally driving.
Just so people realize, if you want to add things with it, you click the things on the sides and then you crank it clockwise. And if you want to subtract, you click things on the side and you crank it anti-clockwise. That's how it works.
You just crank it.
Yeah.
It's quite charming, actually. There's not a single bit of electrons in this thing, which makes it lovely.
I had one. I used one 55 years ago in med school. I was doing some statistical work for a professor, and she had one of these, and said, "Be very careful with it." It was valuable then.
That would take a long time to do those kind of calculations with a CRDA.
I remember.
Cool. I really started something when I put that chat up.
Yes.
Yeah. That was a good look back in time there.
Oh,
Technology
yes.
flashback.
Thank you. So if there's no more about that, or certainly there could be more about that, but Randy, are you ready? You have something.
I'm ready. Okay, do you see my screen, Lunar Puzzles?
Yes.
Very good. So some of you may know that I appreciate things with the image of the moon on it. Certainly my family has figured that one out. And so a couple of years ago, I received this very nice puzzle. Not a difficult one, only 100 pieces. And I thought, okay, I'm going to be pure. I'm not going to look at the picture. I'm just going to look at each picture, each square, and kind of figure out where it was. And I was humbled. I just couldn't do it. And I couldn't, I just didn't know what to think. How could it be so difficult to figure out where I was on the moon? Anyway, once it got together, then I realized it's a crazy picture. Before I give away why it's so weird, does anybody see what's strange about it?
It's wrong. It's
tilted.
torqued. It's torqued. It's like rotated out of phase.
Absolutely, Bill. I mean, look, the thing that's really distinctive, this ray pattern from Proclus, that first of all, it's very hard for a crater to be so asymmetrical. It has the thing that banged against the moon had to be coming in below 15 degrees to make something so asymmetrical. But that is like, there's only one thing that looks like that on the moon. And that's not where it normally is. It's nowhere near the middle. It's way over next to the Sea of Chryses. And Sea of Chryses, you never see looking circular. It always looks like an ellipse. Actually, it looks more like a hexagon when I draw it. But they took a picture of the moon from the side and printed it. And they just talk about how beautiful it is. And they figure that it's normal. Anyway, just to figure out exactly what the thing is, I did crater hopping, and I could see that's Abatenius. And so I just looked through the Rask Victoria website, and I saw this picture of Joe's that was pretty much the same light. So you can see there's a terminator over here, but it's actually in the middle of how the moon is presented to us. That was a pretty crazy puzzle.
So Randy, this is not a view from Earth then?
No chance.
No.
Yeah, because they say on the puzzle, and I don't know, maybe you're reading my mind, Randy. I just ordered this from Boland's because I was curious about it. Yeah, I was curious about it. And it says from NASA photos, right? But obviously NASA has images from the other side. So
well, yeah. I mean, I don't know whether this is actually a lunar reconnaissance orbiter or whether it was, I don't know. I mean, look, it's suboptimal to look at the moon, at the full moon, when the sun is straight on. It's suboptimal because you don't have the shadows to help. But, you see the Mare very nicely. Sea of Chryses, Fecundity, what's that one? Nectar, Tranquility, and Serenity. But yeah, very funny.
A bunch of stuff we don't normally see.
And then back here, like I don't know the back of the moon at all. Okay, so that was a puzzle 2 years ago. Last year, Barbara put out, or I guess she sent an email to me saying, I've just finished doing this puzzle. Do you want to do it? Is Barbara online today? No?
I think so.
Too bad. Anyway, so this is Cobble Hill Puzzles. They're based here in Victoria, and they're very, very nice puzzles. High quality. Anyway, my daughter Hannah and I had fun putting it together. With this one, again, I tried not to look at the picture too much, but basically, if I recognized the name, I knew it was a middle because that's where the near side of the moon is. And then on either side is the far side of the moon. And I just haven't learned that part. Anyway, after I finished it, then I lent it to John McDonald.
And I still have it, if anybody wants it.
I've
done it.
I love puzzles.
It's a nice puzzle.
It's
beautifully made. Is it, John? John, how large is it?
Pardon me?
How large is it, John?
It's 1,000 pieces, and it's about, I don't remember how big it gets, but
it's what?
You can do it on any table.
60, 70 centimeters wide.
Okay, now I can see.
So just 2 weeks ago, I did this one. It's also 1,000 piece, and it's a pretty good. This one's by 4 point puzzles.
Yeah, I saw that one as well, Dave.
But it sat there like someone's welcome to it if they're interested. I put it together. It was my early COVID.
Dave, I'll have to laugh because I told my niece about it, and she says, "Well, how many pieces is it?" Okay, I should have realized she was baiting me because she and her husband do 4,000 piece puzzles, and I sheepishly said 100.
Oh, it's a baby puzzle then, yes.
Okay. Anyway, so this week I got a note from my son saying, "Look on the porch." And this was sitting out there. 4 Ziploc bags. And it was pretty clear what it is it's a moon puzzle, a 3D printed moon puzzle. He got a friend whose father has a 3D printer. He bought the design and then 6 days of printing.
Wow.
To make 240 pieces. And so you have to clip them off. And I suppose it would be possible to look at the pieces and put it together. But on the back of each piece, there's a number. And, just putting it together was quite a challenge. And they give you this lovely icosahedron that you can fold together. So you cut it out and fold it together. And there were 12 pieces in each, of the 20 triangles of an icosahedron. And so we broke it out into bowls and started putting it together. Sometimes with some diagonal cutters to get rid of nasty bits. Sometimes with a file. Not your normal puzzle. Sometimes with a hammer.
Looks like the Death Star.
Anyway, there it is. It's lovely. If you can see my picture. Here we are.
Oh, beautiful.
You're like Urania.
It looks like it holds together quite well now that you've hammered it together.
No. It's not coming apart.
Randy, did you hide something inside of it?
That would be a good idea.
Can you take it apart?
No.
This is a one-time deal. So, there's some things like the thing that is easiest to see is the Mare Orientalis. That's the youngest of the Mare, and it comes out really clear. Clavius, my favorite crater, you can kind of, if you catch the light right, you can see that it's got the little craterlets inside it. A feature that I found works really easily is the Caucasus Mountains ending in with, what's it called? Is that Eratosthenes? So this is the mountain range between the Sea of Serenity and the Imbrium Sea. And you go around and there's Plato. Very hard to see. That's the Alps here. So an interesting thing is, as well as the lunar features, you've got the puzzle pieces that, you know, catch the eye. You have the grain of the printing, which catch the eye. And you've got this hair, you know, these little filaments from the 3D printer. You can see that there. Does any 3D printer in the crowd here know how to get, is there a solvent or something that will get rid of the thin little pieces, but will keep the rest of it nice?
Acetone vapor will do a decent job with a lot of the materials.
Acetone vapor?
You've been inhaling that?
Not too much, no.
No, you don't want to do that.
Do it out in the shed is what I would suggest.
So what, you put some acetone on a hot plate and...
Yeah, I'd have to check. I haven't actually done it. I've just
like
done a lot of
glue.
I've seen it done. It's worth Googling at least.
Okay.
It'll dissolve
it
everything.
Looks like you've added some rills and sheer precipices to the. It's rather dramatic.
Yeah.
Lovely.
So
Anyway,
Randy,
there's the potential to make it worse.
Randy, do you know how the pieces were generated? Is it from data or is it from a
yeah.
model?
Let me just share again. I loaded. You can see my screen.
Yes.
I put this in just in case there is a question. So the Lunar Orbiter Laser Altimeter Selene Terrain Camera. So he got the data. Sounds like he's exaggerated the altimetry a bit, although this is the south and the back where you don't see it very much, but that's where it looks really nice and bumpy. The part of the moon that we get to see is actually quite smooth. So, the really impressive part is that back bit.
Yeah, I would have exaggerated the altitude quite a bit more. The elevation.
I think so.
I think probably gone to 10 times or something.
And then it doesn't say anywhere how he generated the puzzle. This is version 2. Version 1 didn't have the numbers on the back.
Yeah, there's probably some kind of tiling algorithm or something for tiling a spheroid or something like that, I would imagine.
Yeah, like maybe it's just something you take a altimeter model, because he also does the Earth, and so you take the altimetry model and you apply this globe puzzle to it. It makes a sound when I looked at the comments on the website that if it's printed right, whatever right means, the pieces slide together a lot easier. Did not need as much persuasion as we had. And you puzzle people, I don't think you ever admit to using a hammer.
It's cheating, actually.
I like the file idea. Just file off the clang.
Yeah, for that last piece that doesn't fit.
How long did it take you?
Oh, from taking the thing apart to the final piece was over 3 days, but
you had a team.
2 people. 2 people, maybe 5 or 6 person hours. It was totally enjoyable.
Oh, it looks like.
I would love to been able to show you a picture of it actually printing, because I love watching 3D printers at their work.
Yeah.
But it was 6 full days, I think 6 24-hour days of printing to put that together.
A labor of love, but what a nice thing.
Thank you very much.
Yeah, thank you for sharing that. That was
lovely.
Something. Yeah.
Chris Gaynor, do you still have the Edda Karina 3D model I printed for you?
Oh.
Chris is asleep, I guess. Oh, there he goes.
There it is.
What is it?
It's Taurus in the middle of Edda Karina, which I printed on my 3D printer for Chris. It needs to be painted so it looks a little more realistic. It was just printed in white plastic.
That's right. I have it sitting next to Hubble here.
Yeah.
As long as they don't crash into each other.
My very little Hubble.
Very good. Okay, Lori, you had an update for us?
Sure. Let me see. Well, first of all, as I said, I hesitated to even come online because we don't have the calendars yet. And as I say, I'm just completely optimistic, and every day I look out and I really think that it's going to be the day that we're going to get them, but we're not yet. So anyway, as soon as we get them, we'll let you know. So the other thing that I had was, well, actually, the other was the FDAO Star Party, and I'm wondering if I can share the screen. I just have a little thing I would like to
Please do.
I'm hoping that this will work. Okay.
Excuse me.
Oh, nope. That didn't work.
I think you were there, but it went away.
I was there. I'm going to stop the share and do that again because it was there. All right. Wonder what I did. Okay. We'll try this again. Sorry, guys. We'll try this from the beginning. Okay. Terrible picture of the FDAO. So our FDAO Star Party is on Saturday, this Saturday coming.
It's not there.
It's not there.
Sherry hasn't started.
Okay. Dear me, this is a problem today, isn't it? Okay. Let's try this again. Okay. Can you see anything?
Yes, it's back.
Yes.
All right, let's try this again. Can you see this?
Yes.
All right, gosh. All right. So our next Star Party, this is, I've even actually lost count. I think it's about number 20 or 22 or something like that, Star Party since the pandemic started. Saturday, the 22nd, so next Saturday, and it's going to be starting at 7 o'clock, and we should be finished just around 9. We're just going to start to get them to be a little bit shorter these days, because I know everybody just is doesn't want to be online for too much longer, so that's fine. So this time it's going to be on the Sky Cultures of the World, which is the RASC World Asterisms Project. And this has been done and has been put together by Charles Ennis, who is our first vice president of the National RASC from the Sunshine Coast. And it started, I guess, a couple of years ago from the Inclusivity and Diversity Committee with the RASC. It was one of the things, and maybe Bill, you can vouch for that. Is that correct?
Yes.
Yeah, that it started there. And he's put in 1,000 hours of time during the pandemic. And it includes about 4,700 asterisms. And what he is saying, what he looks at is that anything that is kind of put together with groupings of stars and patterns, that is an asterism. I mean, he's going back to the whole thing that the constellation is the 88 constellations that are done by the IAU and are not the ones that are put together with all the little sticks and all that kind of thing. And so he's including all those different different asterisms, and including the position, the position where they are, the names, and the cultural backgrounds of all of these. So just think about 4,700 of these things that he has done all the research, and everything is either has been kind of done through getting information from other people, or people have come to him to say, we've got some other things here that we'd like to add in from some of the cultures from, say, the Middle East, that kind of thing. So he's done a lot of work on that. You can get the links to the Star Party. So the Zoom meeting is here, but you can also just get it on our YouTube channel if you'd like to. This is the one that will be recorded. The Zoom meeting will probably not, because we're not doing that one. So if anybody is interested, we'd love to have everybody there. If you've not seen some of the work that he's done with this, then I would suggest you just chime in. He'll be probably starting at about 7:15 or so, and going for about an hour or so for the time that we have. So we invite everybody to come. We hope that you will. All right. So there's just a couple of other things. One is that, just for your information, is that as chairperson of the Education and Public Outreach Committee for the National RASC, I'm also involved in the Eclipse Committee, which is looking at the eclipses for 2023 and 2024. Now, I know 2023 is an annular eclipse that is going to be again south of us, going through Oregon and dipping down into the eastern United States, going in the same direction as our big one in 2017. The 2024 one is going to be in the east. And I know some people are going to be probably heading south to go and have a look at that. I think, Joe, have you got your place in Mazatlan all ready to go? Is it?
Not yet. It's too far off, but
too far. But it goes through Mazatlan and then up into Texas, and then through quite a lot of quite populous places in the United States, and then right up into Niagara Falls, like around Niagara Falls, a little bit west of Toronto, and then goes back, east of Toronto, I guess, and then heads over into New Brunswick.
It goes right over my parents-in-law's house in Montreal.
Yes, Montreal is right smack dab in the middle. If you're in Welland, I think it's Welland, Ontario. It's a very long eclipse, I think, something like that. So anyway, the RASC has a task force that we have got. The Randy Atwood has been doing some work on this. We've actually had this around for about a year, and we've been working with some of the groups, particularly that are on the path for 2024. And just in about another month and a half or so, we're going to be ordering like literally hundreds of thousands of the eclipse glasses, and each one of the centers is going to be given for free some of the glasses for us to use. Now, we know that, out here where we are, it's going to definitely be partial for both of them. And we may not have the same kind of events that we had before, but we can be ready, and we can, you know, I've said that we probably could use about 1,000 of them, just in case we have some people that would like to put some things out. We'll see what we can do with that. But if any other people are interested in being on the Eclipse Committee, that would be great. I can be, because I've just happened to be on it anyway, I can put some of the data through, but if anybody else is interested, they could sign up for that as well. So, all right, thank you.
Thanks, Laurie. Are there any questions for Laurie about any of those things? Okay, hearing none. Weren't on the list necessarily, but Chris Gaynor, do we have any updates of anything we might want to know? And I think we kind of bypassed you showing off your Hubble Space Telescope there, so maybe we can see it again.
Yeah, let's see, just let me check the, we're kind of in a bit of a quiet patch. Maybe I'll just show you this. Can you see that mirrored segment deployment tracker?
Yes.
So that's kind of what's going on right now. Is each one of those 18 mirrors plus the secondary mirror has a set of actuators behind it, and they are activating them right now. But I don't think you know, I don't think speed is of the essence right now, because the you know, they are still moving out to the right attitude, and things are still cooling off on that side of the telescope, and they can't really seriously start to turn these 18 main mirrors into kind of into one mirror until they get right down to the right temperature. So that's what's going on right now. And the next big date is the 23rd, next Sunday, when it is supposed to, when Webb is supposed to go into its orbit around L2. So they have, I don't think they've set a precise time for that, because they have a fair bit of time to play with. And so that's the next.
Can you clarify for us, when you say an orbit around the Lagrange point, can you clarify a bit there, or explain a bit? How's that work?
Well, it's orbiting the sun. It's called a halo orbit, and so and it's actually, you know, I was kind of looking into that a few days ago, and it's actually, you know, you think it's kind of maybe not that big, but it's actually quite quite a large. It covers a lot of real estate. So you know, I'm not especially knowledgeable about you know, some of the finer points of that, but it's not sitting on or near the Lagrange point. It's just kind of, it's moving around it, and it's quite a long period of time for each orbit. I'm sorry, I've forgotten what it is. No, but I was actually looking into that when I think last week somebody was asking me about how the just a minute, I'm just pulling it up right now. How often the web can, or how the web maneuvers around. So just a second, I'm going to change this around here. Just a sec. Where's Zoom? Okay. Stop share.
So they did test all the actuators and they all work. That was what they did this last week.
They are all working. So, this is you should be seeing a diagram here, which gives you an idea of the light shaded part that we see here is actually the area where James Webb can look at any given time. So it's going to be a little different from a lot of other telescopes, because you can't say, oh, I want to look at this, you know, at Ursa Major tonight, or, you know, see this tomorrow night, or this sort of stuff, because it only has limited movement at any given time, and it has to be in the right point in its orbit. So you might have to wait several weeks to be able to look at a particular point in space, depending on where JWST is in its orbit. And the term for what they can look at is called the field of regard. And of course, regard is, in other languages, means look at. Another thing that you might notice from this diagram is that even though the moon and even though the Earth is between roughly between L2 and the Sun, the halo orbit of JWST will never be in a situation where it is eclipsed by the Earth or even by the Moon, for that matter, because it is running, its power supply is from the Sun. So this is one of the things that have to be taken into account when you look at its orbit. Is that the sun is always within view, at least of the backside of JWST. So let's see. I'm just trying to get this thing to behave a little bit here. And yeah, I think I'll leave it there. But there are actually there's probably lots of people up at the DAO who could explain this a lot better than I can. But anyway, any other questions?
Just a further comment to that, there's lots of good stuff. If you just Google Lagrange points, lots of good articles online about them. And the particularly good ones are the ones that show gravity wells, because then it makes sense visually as opposed to trying to figure out equations.
Yes, you're right. Yeah.
Well, John, this was not something you could have done with the computers back in 1958.
Oh, not with that LG 30 or whatever it was.
Oh boy,
Chris,
would have burned out very fast.
Chris, this is a question not about the Lagrange points, but about the mirror grid itself. You show actuators behind each mirror. Is there any inter-mirror spacing controls, or is that not done? They just made it exactly spaced, exactly apart.
That's a good question. I don't know. I suspect they are, in that respect, they are fixed, but that's a bit of a guess on my part.
I don't know if it addresses your question, David, but I did read that one of the actuators, the central one, is designed to change the shape of a particular mirror. So I think they could change focal part of it.
Yeah, and I guess the only reason to adjust inter-mirror spacing if something got knocked out and they need to true it up. I just wondered if it had any minor impacts, whether it had a way of correcting itself to true itself back up. I guess time will tell.
I did have a question of clarification, if I could, Chris. When you were describing it last week, I was looking into this, like how you were talking today, how it focuses for a period of time while it's orbiting. And I don't know if I read it right or not. Is it true that it's going to focus on one area of space for like 10 days and then it shifts? Or is it sort of migrating as it's looking in that direction?
My suspicion is that it will do both. You know, the Hubble Deep Field photos or image sets were taken by kind of aiming at the same point for roughly 10 days or so. And I've understood that they will probably, well, I know that they're going to be working on JWST deep fields, because JWST, of course, is working in wavelengths that haven't been available before, and so we'll have a variety of observations, including those lengthy ones.
I think that looking at one particular spot for a lengthy time, that's the whole point of it, is to be able to look back and back and back and get the faintest light in the ultra infrared. Oops, I'm at the wrong end of the spectrum. Sorry. Can you go back, Chris, to the picture you had of the various mirrors, because there was one that had a line across it, and I wonder if you can explain to us what's going on, what we're looking at.
Oh, okay.
I mean, I don't want to stymie you. Yes.
There's two, A3 and A6. I think it describes.
That's right. So what's going on? I mean, are these ones that have been collimated?
There's a note at the end there. It talks about them.
Yes. So, I think the difference between them and the other ones is that you know, when they were launched, they were all locked down so that they wouldn't rock and roll during the launch. Mm-hmm. And all of them have been released except for those two.
Ah, okay. So they're the ones that are waiting to be released, not the ones that have been finalized.
That's right. So what they've done is, as I understand it, is simply released them. Or I think the word they're using there is deployed, but they have. I don't think they've really started into trying to get into the fine aiming yet.
Well, they're all at 2, so
they
haven't individually adjusted them.
That's right.
So they've been released to their kind of neutral state, and then when it comes to calibration, they'll be moving around, right?
Exactly.
Each individually.
Yeah. And yeah. The way they were talking about it at the news conference a couple of weeks ago was that they were going to be messing around with some images, but they're just going to be complete dog's breakfasts, you know, until they get down to the fine stroke. So they just have said flat out, we aren't releasing any of that stuff.
It's magic. You know, it's doing it all by itself. I mean, we aren't having any nobody on Earth is having any input into it. It's collimating itself, which is amazing.
Well, another anomaly I noticed on that picture, I wonder if you know, Chris, is if we look at how the mirrors are laid out, they look equidistant, except when you're looking at them vertically, they're closer together than they are horizontally. Is that just an aphorism because of the way it's being laid out here, or are they actually designed that way? And would you know why?
I don't know.
But all the pictures have them beautifully snug to each other.
Yeah, yeah.
I think this is just schematic.
Just a schematic. Okay, that's what I was wondering.
Chris, a question. Are the mirrors collimating themselves, or are they being manipulated from the ground? Like each actuator being manipulated from the ground.
What I read about it was that it's being done by the ship itself. The telescope itself is doing its own collimation. Because it takes.
I would imagine that the people running it are keeping a very close eye on it, and you know, if necessary, they would be making adjustments.
But I would guess there's probably a computer program that's controlling the actuators that was pre-programmed to do what it's doing, I would guess.
Yeah, I think that code probably would be resident on the telescope itself.
I think
it
so.
would be kind of like an autofocus, I guess, so
It'll
to
be
speak.
8 or 9 seconds each way for a signal to get there.
Yeah. But I would imagine they must have some.
Makes it difficult.
Yeah, they must have override, you know, through communications.
They'd be monitoring it closely, I'm sure.
Yeah.
Oh, yes. Well, it tells each one as it's collimated. It says, okay, now this one's all right, and we're moving on to the next.
Well, they'll just be making a point out of it. They'll focus on a star and then just keep adjusting until the star becomes the smallest.
Mm-hmm.
Yeah.
So it could do it automatically. And then at a point, if that fails, they could send some new program to fine tune it. Because it would be able to just keep reading the size of the spot and adjust until it becomes small.
But I would say that because we are talking about 18 different segments here, this is far more complicated than us, you know, collimating, you know, something up at the, you know, at the, you know, in our own telescopes with.
Well, I think it's probably multiple stars that they're trying to put all together. Like you get a star from each mirror, and they're probably in different spots, and you just got to put them all together.
I think they do them one at a time, but it's going to take weeks.
That's right. That's right. And you know, they don't expect that it's going to be kind of operational really until June. So.
Yeah, that's probably what's going to take so long.
That's right.
Getting these.
That's right. This is just, it's just incredibly complicated. This part of it.
And I assume they've left those two behind to not cause any, I guess, because they, with the exception of a few of the outer mirrors, the A3 and A6. Border on every other inner mirror and about half of the outer ones. So maybe by keeping them out of the way, you can get the other ones out and aligned and then move those, and those are then programmed to move into position. I'm just guessing here, but. And then they'll just they'll move them into their final position later on. Interesting. Well, thank you for showing that diagram. That's quite neat.
Oh, yes. I'll read up more and more and more.
Well,
freaky complicated.
Well, so far so good. It looks like it's, from what I've heard anyways, that things have gone quite well. So it's looks like it's done what it needed to do so far. So we'll hope that it gets to where it's supposed to be on the weekend, and then they can start doing stuff with it.
Oh boy, it's going to be exciting. It's a good time to be alive as an astronomy student.
Yeah, it's certainly a very exciting time, because this is, well, assuming it all works as planned, it's quite pretty groundbreaking in terms of putting something that large into space that far away and have it all roll out and work is really cool. So anyways, yeah, thanks again, Chris, for keeping an eye on what's happening and keeping us posted. I don't know if anybody else had anything for this evening, but maybe
Chris,
Margie could, oh yeah, could Reg, and maybe Margie, just towards the end there, you could just give us a reminder about, is it Tanya next week? Yeah, so Reg, you wanted to say something.
Can I share the screen, Chris?
Please.
Okay, do you see a picture of a calendar?
Yes, it is, yes.
Okay, that calendar is on Vancouver Island, and it's the Rask calendar. And I dropped by Nelson Walker's place on Saturday, and he proudly showed that to me, as well as his handbook. So it's the first 2022 handbook I've seen physically. So Nelson is at the leading edge. He got his calendar. He didn't go through the Victoria Center. He ordered it online. So, and it had arrived on Friday, I think. So it's fairly near here. So while I was talking to Nelson, I proudly showed him the new camera that we have on the back of the scope up in the hill. And he took one look at it and he said, "Reg, that looks like an oil refinery." So I don't think he wasn't all that impressed with that, but he has got a great sense of humor. So I wasn't too offended. But I wanted to, we were talking about computers earlier on, so I wanted to go back to a non-electrical computer. And I was up at the attic of Vic High some time ago. And this is a Pickett slide rule that they use for instruction. And I just happened to own the very same model myself. So I want to explain this particular slide rule is for large numbers, and this slide rule is for small numbers.
Very good.
And I'll stop the share.
All right.
That's crazy.
And they both only do 3 places.
Yeah. I like that pocket version is great there, Reg.
I guess I'll have to take out the Hughes Owens in its leather case to show you one of these days.
Yeah.
The initial slide rule for first-year engineering students when I started.
Yeah.
Yeah, we could bore everyone with a whole slide rule night.
Yeah, probably.
Maybe we should do that offline.
Yeah. Have a slide rule sig. There we go.
Oh, brother.
I was going to say we need to have a historical sig.
Yeah, we are. Yeah. Great. Well, thanks. Did we lose Margie? Oh, I don't see Margie here. Oh, there you are. You moved over there now on my screen. Yeah, if you want to just remind us about Tanya for next week.
Right. Tanya Harrison, Dr. Tanya Harrison is speaking to us next week. She is the gal who is the professional Martian. She's worked on multiple NASA Mars missions. Her specialty is in geomorphology. She has a master's in Earth and Environmental Sciences, and I'm sure she will be not only informative, but fun.
Yeah, and she's joining us on East Coast time, is that right?
Yes, she is.
Okay, so she's staying up late to talk to us, which is great.
So we'll certainly... Margie, sorry, Chris. Margie, do you know the runtime of her talk?
I gave her an hour.
Okay.
Which would include questions. Or not, as she saw fit.
So we may or may not have time for our regular kind of installments, which is fine.
Yeah. So David will be host next week. of the overall thing, and Margie will be Tanya's host. So thank you for taking that on. Are there anything else for this evening?
I have an oddity.
Okay.
So, can you see the thing in my background?
Yes.
Okay, so that is like the rarest mushroom that's been found on Vancouver Island. I found it last week. Oh. So have anybody ever heard of things called cordyceps? And I'll tie this into astronomy a bit. So they're a mushroom that they're the zombie mushroom. They invade insects and then take control of them and make them do things so that they can populate. Ooh. So I was out for a walk with my dogs the other day, and they were just only the yellow bits were sticking up above the moss. I could see these little tiny fingers. And this is out on the hill by the observatory at Pearson. And this is where it ties in with astronomy. I could only find 3 other incidences of being found. So at the very bottom of it, where it's in the white there, at the bottom, that's a pupa of that's the pupa of a caterpillar, of a moth. Wow. Okay, so they invade it when it's pupating underground and take over it and then sprout up, and those are the mushrooms sticking up. So when I went looking online, Adolf and Aluna Chescu, they've done a full mushroom analysis for 20 years on Observatory Hill up around Little Saanich Mountain. And they have found it several times up there. So 2 of the 3 times it's been found next to an observatory. And
what's it called?
Well, this one is called the scarlet caterpillar cordyceps. And I found another person has found it in sort of the Oak Bay area. And I need to look closer at the map now because it sure appears to be close to Gonzales Bay, which would be another observatory. So I have to look at the map closer of where it was found, because if it was found next to 3 different observatories, it needs a new name.
Go and explore around Sid's place there too, and Gary, once you get your new place, well, we'll have to keep it.
Maybe it's not a mushroom. Maybe it's a wormhole.
Well, they're the rare mushroom that they find in Tibet, where they invade a caterpillar, and they're used as a medicinal mushroom, and they sell for thousands of dollars a gram. And they take over ants and make them crawl, like they take over their bodies. And the last thing they invade is their brain, and they make them go to like the top of a twig and then just freeze up. And then the mushroom sprouts out of it so it can send its spores all over. So they're the thing called the zombie mushroom, because they make insects do things to help put them in a beneficial place for them to spawn. But I just thought the 2 observatory things was quite unique, right?
Be able to put everybody's mind at ease. Apparently it can't infect the human body.
No.
Hasn't crossed the species boundary yet.
These are really tiny. Like you can see the moss next to them, the little thing of moss. They're just like, the big one is maybe a couple of centimeters long. It only showed up because they're bright yellow against the green. And then I didn't even know what it was at first. I just took some pictures and put them into iNaturalist, and then it told me it was a cordyceps. So I had to go back there the next day and find them and dig them up so that I would have them as a collection. So they're dried out now and in a little container sealed up.
They're probably not edible, right?
I wouldn't try it.
I don't trust them.
The ones that they take from like the Tibetan plateau, those are used as an edible mushroom. It's that same thing that the Asians are always taking odd things, rhino horns. It's all about the men.
Getting the women to freeze in position. Yeah, right. I think we stop there.
Yeah.
I'm still curious about the third location though, because now I need to go look to see how close to Gonzales Hill it is.
Well, thank you for finding that and telling us about it. That's really cool. Great. Anything else for this evening, or should we call it a night? I think we're calling it a night. Yeah, I think that's
okay. Well,
so thank you so much for joining us.
And thanks for moderating, Chris.
Yeah, we'll hopefully see everybody next week. I hope to be able to attend, but I won't be necessarily in Victoria. So
a little biology, a little history, a little science, a little
computer science. We did
everything tonight.
Oh, yes.
There we go.
It was very entertaining tonight. Thank you all.
Okay.
Yeah.
Bye, everybody.
Good night.
Good night.